Today, we're going to go over standard normal probabilities. We're going to start with this problem. A university calculated that the mean combined SAT score of its new freshman class is 1,060 with a standard deviation of 120. Assuming the scores are normally distributed, determine, and then we have parts A, B, C, and D. Before I get to those, let me just give you a little bit of a background on the problem. You all know that universities tend to accept students based upon their SAT scores or ACT scores, but in this problem, SAT scores. And the combined score is the verbal part and the math part. I didn't include the newer writing or essay part or whatever they call that. We also assume that the scores are normally distributed. You could look up a definition of what normally distributed data actually means. For my live classes, I give you that definition in class. Let's take a look at problem part A. For part A, we want to determine the proportion of students who were admitted with a score between 1040 and 1190. So let's go to that problem. A normal curve, otherwise known as the Gaussian curve, looks like this. There are very few scores, in this case, that fall on the outskirts of the curve, either on the left side or the right side. When we talk about the normal distribution, we talk about these ends as being the tail. And of course, the one on the left side is called the left tail, and the one on the right side is called the right tail. Also, when we talk about the normal distribution, it tends to peak in the middle, meaning that most of the scores fall somewhere in the middle of what this curve would look like. What I have here, though, is not the standard normal curve. This is just a curve that shows that the data is normally distributed. In other words, yeah, there are a few people who got as low as a 760, maybe an 840, 900. Most students you could see scored like around here between a 960 and maybe 1160. Somewhere in there are where most of the scores are. And this curve is a normal curve, but we didn't standardize it yet. Let me explain what that is. Okay, this represents the mean, the very center of the curve and the peak point where the x value is on this x-axis. That represents where the mean is. As I have over here, we're concerned about the scores between 1040 and 1190. Here I have that region shaded, and it looks like a lot of stuff falls in that range. A couple of other things about just normally distributed data. The mean and the median and the mode are pretty much the same number. They're close enough to where we call them the same number. So what that means is half of the data falls to the left of my mean and half to the right. So for example, if I just asked the question, what proportion of students scored above a 1060? Well, that's my mean. So that would mean that half of the students, or 0.5. Similarly, if I asked how many students that were admitted to this college or university, scores fell to the left of my mean, or to the left of 1060, that would also be 0.5. We don't have a spreadsheet lookup or a table lookup that represents just any old normally distributed data. So what we do is we play around with it and we standardize it. This process is, well, it's done behind the scenes. You don't really see what you're doing when you standardize and normalize it. So for right now, let me just rehash what I was saying, that this axis represents the x-axis, and we're all the way out at 1060, where the mean is. Now, part of the standardization process is we take this center area right here where the curve peaks, and we move it all the way to the left, in this case, so that the mean lines up with 0. In other words, the mean becomes the y-axis. Additionally, what we do, and this is behind the scenes, it doesn't necessarily look like we're doing this, but this is what we end up doing. Behind the scenes, what happens is this is the y-axis, and so that means that the mean is 0. And this we convert to what's called a z-axis. Now the z-axis, for the z-axis, what we end up doing is crunching it all together, and we have a standard deviation of 1 and a mean of 0. So that's the standardization process. Let me show you what this exact same data would look like on a standard normal curve. This is what the standard normal curve looks like. As you can see, it still has basically the same shape as just any old normal curve, meaning the previous one that we just saw with a standard deviation of 120 and a mean of 1060. Then this one has a mean of 0 and a standard deviation of 1. We shifted the entire curve over so that mean became 0, and then we scrunched it together. So instead of having a standard deviation of 120, we now have a standard deviation of 1. The way this also works is instead of this axis down here being an x-axis, we now call it a z-axis. And the z-axis represents the number of standard deviations away from the mean. I already have this shaded to where it would correlate to the problem at hand, where we want to find the proportion of students admitted with a score between 1040 and 1190, and this is what the shading would look like. Let me show you how I got there. We're going to do this by spreadsheet mode, and then I'm going to refer back to diagrams as we go along. But we're going to do that in the next video, so stay tuned and play the next video, and we'll go through part A of this problem, and in the third video we will go through the remainder of the parts. So as I said, stay tuned for those.